Cambridge IGCSE 0625/42, October-November 2024, Paper 4, Theory, Extended. Full paper walkthrough. Question 7. A washing machine has an electric motor and an electric heater. Figure 7.1 shows a simplified circuit diagram for the washing machine. The heater has a resistance of 25 ohms. So the heater has a resistance of 25 ohms. And the power supply has an EMF of 230 volts. 230 volts. Part A. State the meaning of an electromotive force. EMF is electrical work done by moving a unit charge around a complete circuit. State the potential difference across the heater. So we know the power supply is 230 volts and the heater is connected in parallel to the power supply. So the voltage of the heater is equal to the voltage of the power supply, and that is 230 volts. Calculate the current in the heater. So we can use V is equal to IR. As we know the voltage and the resistance of the heater, we can calculate the current. That's 9.2 amps. The current in the electric motor is 1.6 amps. Determine the reading on the ammeter in figure 7.1. Explain your answer. So the current here is 9.2 amps, and in the motor the question says the current is 1.6 amps. So here these two would combine, so it would be 9.2 plus 1.6, and that would be the reading of this ammeter. So that's the answer for this part. And the explanation is sum of currents into the junction is equal to sum of currents out of the junction. Question 8. A fisherman uses a high frequency sound wave to locate fish in the sea. Figure 8.1 shows the sound waves emitted from the boat. State the name of the sound wave with a frequency greater than 20 kHz. Ultrasound. High frequency sound waves travel from the boat to the sea water. The speed of sound is 1500 meters per second. The seabed is 22 meters below the boat. Calculate the time taken for the boat to reach the reflected wave from the seabed after the sound is emitted. The sound is emitted and it hits the seabed, and then the sound returns to the boat. So they're asking the time for that. So in the reflected wave question, we have to use speed is equal to 2d by t. Time is equal to 2d by speed, and the distance is 22 meters divided by the speed, which is this 1500 meters per second, and that would give 0.029 seconds. Figure 8.2 shows fish below the boat. Describe and explain how the reflected sound wave received by the boat from the fish differs from the reflected sound wave received from the seabed. The reflected wave is weaker. Only a small part of the wave reflects off the fish. Question 9. Figure 9.1 shows a wireless charging plate used to charge a battery in a mobile phone. The coil of a wire is a part of an electric circuit. The charging plate is connected to an AC power supply. The power supply is turned on. Describe the magnetic field around the charging plate in terms of magnitude and direction. The magnetic field around the charging plate is constantly changing in magnitude because the current is alternating, and it is stronger closer to the coil of wire. The magnetic field is perpendicular to the alternating current producing it, and it changes direction as the current reverses. This is a 2-mark question, but I've included 4 points. But writing any 2 points would get you the 2 marks. Part B. A mobile phone is placed on a charging plate as shown in figure 9.2. The coil in the mobile phone is part of a separate circuit that charges the battery. Okay. Mobile phone, the secondary coil, the charging plate, and the primary coil. The coil in the charging plate and the coil in the mobile phone act like a transformer. Explain why there is a current in the secondary coil as shown in the figure 9.2. So here's a secondary coil, and we are asked to explain why there is a current in the secondary coil. There is a current in the secondary coil because it is in a changing magnetic field produced by the primary coil, which induces a voltage in the secondary coil. Suggest why the transformer made from the charging plate and the mobile phone is not 100% efficient. Because some energy is transferred to thermal energy. Part C. The mobile phone battery can be recharged using this charging plate and stores 4.5 times 10 to the power 4 joules of energy when fully recharged. The current in the secondary coil is 0.63 amps when the output voltage is 12 volts. Calculate the time taken to fully recharge a completely uncharged battery. We have the energy, we have current, and we have voltage. And we are asked to find a time. We can use this equation to find the time taken. And that would give us 5952.3 seconds. That's 6000 seconds. Calculate the charge passing through the battery in 60 seconds. We can use Q is equal to IT equation. We know the current, that is 0.63 amps. Multiply the time, which is given as 60 seconds. That gives us 37.8 coulombs, and it's 38. Question number 10. Carbon-14 is a radioactive isotope of carbon. Carbon-12 is not radioactive. Explain how an atom of carbon-14 differs from an atom of carbon-12. An atom of carbon-14 differs from an atom of carbon-12 because the nucleus of a carbon-14 contains more neutrons. For example, the nucleus of carbon-14 contains 2 more neutrons than carbon-12. Part B. All living organisms contain carbon-12 atoms and carbon-14 atoms. The ratio of carbon-12 to carbon-14 is 1.1 times 10 to the power 12. Carbon-14 has a half-life of 5,700 years. When an organism dies, no new carbon is observed. The amount of carbon in the dead organism remains fixed. Describe how the amount of carbon-14 in the dead organism decreases with time. After an organism dies, the amount of carbon-14 in its body decreases over time. Every 5,700 years, which is the half-life of carbon-14, the remaining amount of carbon-14 is reduced by half. This means carbon-14 continues to halve every 5,700 years, so the amount decreasing at a decreasing rate over time. A sample of a wood contains carbon-14 to carbon-12 atoms in the ratio of 1:4 times 10 to the power 12. Calculate how many years ago the tree died. So carbon-14 to carbon-12, this ratio is 1 is to 1 is to 4 into 10 to the power 12. And this is the ratio now. That is 1.1 is to 1 10 to the power 12. So from here, the first half-life, it would give 2 into 10 to the power 12. From here to here, that is the second half-life. So there are 2 half-lives here, and each half-life is 5,700 years. So 5,700 times 2 would give you how many years ago the tree died, and that's 11,400. So 11,000 years ago. Other radioactive isotopes have different half-lives. Suggest the use of a radioactive isotope with a half-life of 1 hour. Explain why a short half-life is suitable for this use. Uh, Radioactive isotopes can be used as a medical tracer, and the explanation is it does not stay in the body for too long. Question 11, Part A. State the name of one planet that has an orbit further away from the Sun than Venus. You can write any one of these planets. State the name of one planet that has an orbit closer to the Sun than Venus. Mercury. Venus has an average orbit radius of 1.1 times 10 to the power 11 meters and an orbital period of 220 Earth days. Calculate the average orbital speed of Venus. Give you an answer in meters per second. Okay, so we know the radius is 1.1 times 10 to the power 11 meters and the orbital period is 220 Earth days. And we asked to find the speed. So we can use speed is equal to distance over time equation, but we need to work out the distance. And the distance is the circumference. So we can use 2 pi r in order to work out the circumference. So that would be, and we also have to convert the time. So to convert 220 Earth days into seconds, you have to first multiply it to work out the hours, and then minutes, and then seconds. So when we put this together, you would get and that can be written as 3.6 times 10 to the power 4, and the unit is given. State the relationship between the orbital speeds of a planet and their distance from the Sun. The further away from the Sun, the slower the orbital speed. Comets are balls of ice and dust. Some comets orbit the Sun. State and explain the speed of a comet changes as it orbits the Sun. Explain your answer using the ideas about the conservation of energy. You may include a label diagram below. So the comets will be orbiting the Sun in an elliptical path. That's important. And here, when it's further away from the Sun, the kinetic energy would be lower and the gravitational potential energy would be higher. And as it moves towards the Sun, the kinetic energy would increase and the gravitational potential energy would decrease. And as it moves away from the Sun, the gravitational potential energy would increase and the kinetic energy would decrease. Say if it's 50 joules here, the total energy near the Sun would be also 50 joules. And this is because the energy is being conserved. So that's all for this paper. Thank you for watching. If you have any doubts, please drop them in the comments.